Next, we are going to see with kinetic energy in pure rolling. So already we have seen with what is pure rolling is. Yes. And now we are going to see the value of kinetic energy in this pure rolling. As pure null and it is a combination of what? Translational as well as a rotational. We can write the total kinetic energy. So total kinetic energy is equal to what? Sum of the kinetic energy due to translational and the kinetic energy due to rotational. So kinetic energy is equal to kinetic energy translational plus kinetic energy rotational. Clear? Now we are going to write the equation for this translational and the rotational. What is the formula for translational is? It is half m into v square, okay? Because we know 1 by 2 mv square. This is the general formula for kinetic energy. Now, translational abdinamode, we are writing with this same value. Rotational abdinamode, instead of m, we are writing as I, moment of inertia. V, it is angular velocity, omega. Okay, so that is what is set here. If the mass is m and velocity v of cm and the moment of inertia I of cm, angular velocity omega abdina, then we get the equation for kinetic energy, which is half m v square cm plus half I cm into omega square. Okay, and just know with this equation. Next is with reference to the center of mass. Okay, with center of mass as reference, what we are going to do is the moment of inertia is I is equal to what? M into k square. So this we know already, the formula for moment of inertia, which is I is equal to m into r square. Now instead of this r, we are writing it here as k. Then, what is the relation between linear and angular velocity is v is equal to r omega. V is written here as v of cm, r is capital R and omega as it is. Okay, and so if you substitute this in the before equation, we have I of cm into omega square. So இதிலிருந்து உனக்கு omega வேணும் அப்படினா என்ன எழுதலாம்? This you are bringing here. So this becomes is p of cm divided by r. This is omega. So we need the value of what? Omega square. So when you square this, we get v of cm square divided by r square. So this is omega square. Yes, then I into omega square as it is. Yes, now just multiply this outside and bring this v square inside. Okay, so we'll be getting the equation as kinetic energy, which is equal to half m v square plus half m v square into k square by r square. In this, half m v square is constant, common. So we are taking it out. Then the remaining is what? 1 here. Here the remaining term is k square by r square. So writing this equation as it is. So this gives the equation for what? The kinetic energy with reference to the center of mass. So the equation is half m v square cm into 1 plus k square divided by r square. Okay, so with reference to the center of mass. Clear? Next is we are going to have with reference to the point of contact. So when we have the point of contact, just only one point will be considering. First, center of mass அப்படின்றதுனால this point will be moving. So we'll have both translational as well as rotational. Here we are having one equation, which is half I naught into omega square. Okay, half I naught into omega square. Now we are going to substitute the equation for this I naught and omega. So I naught and equation we are going to take from parallel axis theorem. So what is a parallel axis theorem? Equation is I is equal to IC plus m into d square. So this is the equation for I. Here instead of I, we are writing as I naught. IC is ICM, m as it is. Instead of d square, we are going to write it as r square. Okay, then I of cm is already equal to what? Just now we saw, which is equal to what? M into k square, is it not? So substitute this value of ICM here. So I of cm is equal to what? Mk square plus mr square, and we know the value of v of cm already, which is r into omega. From this we need the value of omega, so bringing this term down, omega is equal to v of cm divided by r. Now substituting with the value of I naught and omega in the equation for kinetic energy. So what is the equation for kinetic energy? Just now we have seen here is half I naught into omega square. This is the equation for kinetic energy, is it not? So I naught, you substitute this equation. Omega we are going to substitute with this equation, so that the equation becomes as kinetic energy is equal to I into omega square. This is I naught. So I naught is equal to what? Mk square plus mr square into this. Okay. Now multiply this term inside. Okay. So if you multiply this inside, we'll be getting the equation as half. I'm writing it common outside. Then the remaining is mk square into vcm square divided by r square plus this term also we are multiplying inside, so we get m r square into v cm square divided by r square. Yes, now this value of r square and r square get cancelled. Okay, so the remaining is half into m k square into v cm square divided by r square. This is the first term, and the second term r square has been cancelled, and so the remaining is what? Just m v square c m. Okay, in this m v square cm m v square cm, so both are constant. If you are taking it outside, okay, so we get this term. If you are taking outside, this becomes as 1, is it not? And this both we are taking outside, and so the remaining is what? K square by r square. And so we are getting the equation as kinetic energy is equal to half mv square into k square by r square. So this is the same we have got before also. So we can say that all the values, the kinetic energy is same. So the kinetic energy does not change even for the point of contact and also for the center of mass. Pure rolling has two cases, the combination of translational and rotational, and also only the rotational for the point of contact. Clear with this?